Alright, hey guys, what's up? Welcome to T-Ski Tutorials, and this is FPS 1.42. So, today's episode should be really cool. I'm going to go ahead and just cut the video and go into screen recording so I can give you a preview of what's to come. So let's roll that clip now. Alright, let me give you a quick demonstration of how this inverse kinematic arm system actually works. So let's go ahead and give this game a run. And the first thing you might notice is, well, first of all, our enemy has arms that are holding a gun. And the gun is actually a really nice model. It's not textured yet, but it is a model, which is definitely a huge step up from cubes. And I'd have to say it's pretty badass looking. And this model will now be available when you actually download the game. Or when you download the project reference files, this gun will be available, and it was modeled by YouTube user Digimbyte. So if you want to go over to his channel and give him a big thank you, click the screen right now. So, or you can check the link in the description. I will also link his channel in the description. He has a time-lapse video where he actually showed this gun being made, which is pretty cool. Alright, so first of all, let me show you. Gotta click on this right here. So, the arms snap to the gun right here and right here. So let me find a good angle so that you can see. And when I move the gun, the arms move with it, no matter where I move the gun, unless I move the gun too far that the arms simply can't reach it, and then they just reach as close as they can get. So I can move it in any direction and it will still hold the gun. And then I can also rotate the gun in any direction and the arms will hold it. I can even rotate it that way if I wanted to. So yeah, that is pretty cool. So why don't I take the enemy, and I'm going to change this variable right here to something more like 0.5, and let's save it and then give this game a run, and let me show you some of the other cool features that have been added. You know, actually I'm just going to go ahead and make that full screen. So yes, as you can see, I'm using the modeled gun right now from Digimbyte. And I'm going to wait for the enemy to actually see me. Do you see me? Yes, he does. And he's shooting bullets. And I'm trying to dodge the bullets to kind of show you that the gun has recoil. It might be hard to see. And oh, he just killed me. And that is the dying animation, which it actually isn't an animation. It's dynamic because it uses a rigid body. And what I really like doing is killing myself, or letting the enemy kill me while I am on a slope, because watch what happens. This is really cool. Come on, shoot me, kill me, kill me, shoot me, thank you. I actually roll down the slope. How cool is that? And no matter what, or I don't know about no matter what, but it is highly unlikely that the camera won't be sideways when you land and die. So it's actually built so that, here, I'll actually just show you what it looks like. It's actually a prefab right here. That's what it looks like. It's really weird looking, but when you don't know that it's there, it works very well, and it's just a shape that will typically land on its side. So that way you're not looking straight at the ground or straight up at the ceiling at things that are typically going to be less interesting than looking sideways at enemies that are still running around, and parts of the level that are more interesting than the ceiling or floor. So yep, that is what we are going to be doing in the next 3 tutorials. So let's get back to FPS 1.42. Alright, so I always knew that the enemy needed to have a gun, but I've been stuck on the problem of how do I make that enemy hold the gun. At first I was thinking maybe I could have the arms do the up and down rotation and the torso do the left to right rotation. But that really wouldn't be very accurate, and it's a little bit problematic. So I came up with the idea of, why don't we just have the gun float where it needs to go, and then use trigonometry to make the arms snap onto the gun. So the arms are always going to be following the gun very precisely, so it's going to look like the arms are holding the gun when really the arms are following the gun and the gun is holding itself. And you guys probably saw me posting a video about talking about this idea, and I got a lot of comments in that video saying, dude, that's called inverse kinematics. Sure enough, I Google searched inverse kinematics. That was exactly what I was trying to do. And not only that, but it turns out that there is a free asset on the asset store that somebody made of a pre-made inverse kinematic system, which was basically the exact thing that I'm going to be creating in this tutorial. So rather than just telling you guys, hey, go and download this asset from the asset store, I figured I might as well make a tutorial and show you guys exactly how it was made, because that's the best way to learn, is to break something apart and actually look at how it works. And not only that, but I was like halfway through figuring out how it was going to work, and I didn't want to just give up and download somebody else's stuff, so I wanted to create it myself, and I did, and it's really awesome. So yeah, let's actually get started in the code and the equations of how this all is going to work. Okay, I couldn't find my airsoft gun to use as a demonstration, so I'm just going to use this big knife instead, and I'm going to take this tag vest off because it's just kind of stupid. Alright, so anyways, so basically what we have is, here is the point that we are trying to get to, or our target, and we can have this just be an empty game object with a transform that we set as a child to any object that we want the enemy, or really any arm, to hold. So this could be a gun, a knife, a sword, whatever you want it to hold. Alright, and then we have the shoulder point right here. So this is going to be the point that is locked down, or not really locked down. You can move this point around and it will still hold what you're holding accordingly. So we have this point and we want it to get to this point, and then we have this, your forearm and your bicep, which in the code I called the wrist and the shoulder, even though this is your shoulder and I'm really talking about the bicep. But anyways, these two objects have a length that is not going to change, and they are going to pivot around this point here and this point here and meet right here in the middle. So the way that this system is going to work is that there's going to be a parent empty game object right here that is going to point at the target that we want it to grab. And then we're going to use trigonometry and some other math to figure out this angle right here, because right now we have a straight line that's pointing from the shoulder to the gun, so we need to find this angle right here and this angle right here, so that this game object and this game object meet exactly right here in the middle. So basically, it's really easy to make the parent's game object point directly at the target. That's just a, transform.lookAt function. So then after that, basically all we have is a triangle like that. And we know the three variables, the distance between the shoulder or the parent's game object to our target, and then we have the length of the forearm and the length of the bicep, or the length of the wrist and the length of the shoulder. So we know 1, 2, 3 lengths. So those are the variables that we know. Now we need to find some math to actually break it down and figure out what this angle is going to be and what this angle is going to be. Almost just stabbed the shit out of my foot there. Okay. Alright, now I'm going to start talking about circles. And you're probably going to be like, wait, what? I thought you were talking about triangles. Well, there are actually circles inside of the triangles that we are trying to find. Because, I can hold the knife. Alright, so we have a constant length right here and a pivot point right here and a constant length right here and a pivot point right here. So a circle basically is a big curved line that is always an equal distance away from a center point. So that basically gives us a circle right here and a circle around the shoulder. That's very awkward to do right here. So now we have two circles, and we need to find the intersection of those circles to be able to find the distance at where the elbow needs to be. Because right now with the trigonometry, we can't figure out this angle and this angle without knowing this, or the Z or the X of the elbow right here, because we need to use the SOHCAHTOA trigonometry theorem. I don't know if it's a theorem or equation. And we need to be able to know the length of the adjacent side and the hypotenuse. But right now, all we know is the sum of two lengths of two separate triangles. So what we're trying to find from the intersecting circles is the distance right here, so that we can know the length of the two adjacent sides of these two separate triangles, so that we can actually use this SOHCAHTOA equation. So why don't I pull up the website where I actually found exactly what I was looking for in the equations that I needed. So as you can see right here, we have basically the triangle. So this would be the shoulder, this is the bicep, and this is the forearm, and this is the point at which we are holding the gun. And as you can see, it makes two circles like that. And let me scroll down here. Right here is the equation that we need to find line X. So, or not line X, but we have a variable right here that is labeled as X, and as you can see, X equals D squared minus R squared plus capital R squared, all divided by 2D. So that will give us this length here, or in other words, it will give us the distance between the shoulder and then going straight forward to a point that is right above the elbow. Alright, so here's going to be an extremely fast crash course on trigonometry. So you might have heard some people say SOHCAHTOA when they're talking about trigonometry, and that's just some little rhyme or word that somebody came up with. It's actually very useful for remembering how sine, cosine, and tangent work. So the first part of SOHCAHTOA, SOH, S-O-H, is sine of the angle that we're looking for equals the opposite side divided by the hypotenuse, which is the long slanted side. And then co, which is cosine of angle B, is equal to the adjacent side divided by the hypotenuse. And then tangent is opposite over adjacent. But for this case, we really only need cosine. So in this case, this is a little bit upside down, but this angle B would either be the shoulder or wrist, and then the hypotenuse, this long slanted line, will either be the forearm or the bicep, and then the adjacent side will be the distance between the shoulder to the gun divided at the length of the elbow going straight up and down. Alright, now let's first take a look at all of the variables that we're going to be putting inside of a new script called the inverse kinematic arm script. So the first variable is target, and this is going to be a transform. And this is pretty self-explanatory. This is what we are reaching for and trying to grab. And then our next variable is hand transform. So what we're going to be doing is, once we have found the position where the wrist needs to be, we're just going to go ahead and slap the hand right on top of it, because the hand doesn't matter as much. It can just snap right onto the handle of the gun, and really we just need this point right here to pivot. So that's why we need the transform of the hand, so that we know where to place the hand. And then we have the shoulder transform. Now this isn't going to be the parent game object. There's going to be a parent's game object and a shoulder game object, and the shoulder is going to be a child of the parent game object that all of these things are going to be inside of. So the parent game object, its only job is to basically point at the target, and then the shoulder and the wrist job is to move in and out and forward and backwards from there. So we need the transform of the shoulder so that we can access that later. And then we need the shoulder elbow point. So what we're going to have is a game object that is going to be the shoulder game object, which is going to be a child of the parent game object. And then as a child of the shoulder game object, we're going to have the model, or in this case, we're just going to use a cube, but later it can be replaced with an actual model. And then we're going to have the elbow point. So what this is going to be is just an empty game object, just to reference exactly where the elbow is so that we know the exact length of the shoulder, because it would be a little bit annoying and not very accurate to try to guess this length ourselves. So we might as well calculate this right in the very beginning and just let Unity do that for us. And then we have shoulder length. And this goes right off of the variable shoulder elbow point. Shoulder length is going to be the length of your bicep right here. So saying shoulder is a little bit misleading, but that's just what I called it. So that is going to be the length between the transform of the shoulder and then the elbow point. So yeah, the length of your bicep basically. And then we're going to have three variables that are going to be the exact same thing, but instead of up here, it's down here. So we have wrist transform, so that's going to be this point right here. And then we have wrist elbow point, which is going to be this point right here. And then we have wrist length, which is going to be calculated, and it's going to be the length between the wrist and the elbow point so that we know how long the forearm is. And then we have a variable called elbow weight, and this is going to be a transform. And basically this is just going to give us the up rotation when we do the transform.lookAt function. But basically this is going to be a point that we can stick kind of around the arm or on the enemy character that just shows where the elbow is going to sort of point at, because otherwise we're going to get some rotations where the guy's going to be holding the gun like this, and that's very unnatural. So we need some weights for the elbow to actually try to like target itself towards. And then we have elbow Z and dist to target. So dist to target is going to be a variable that is constantly going to be changing, and it's going to be the distance between the shoulder and the gun. And this might actually extend the reach of the arm, but we'll get into that later. And then elbow Z is going to be the calculated point, which is going to be how far away on the Z axis the elbow is away from the shoulder. And the reason why I called it elbow Z rather than elbow X is that in this case we are reaching straight forward along the Z axis. So you're reaching at something, or just kind of imagine yourself going through the equation. So that is why we're using Z rather than X, because we want the arm to go forward. Alright, now let's move on to what we're going to be putting inside of function awake. So really the only thing that we're going to be doing is calculating the length of the bicep, or the shoulder length, and the length of the forearm, or wrist length. So that is simply shoulder length equal vector3.distance, shoulder transform dot position, comma, shoulder elbow point dot position. So vector3 is a function that is inside of the vector3 class, which measures the distance between two vector3s in world space, or a simulated world space, really. But basically it's just going to give us the distance between the shoulder and the elbow point so that we know how long this is going to be, so that we can use that information later. And then we're going to do the exact same thing with wrist length, but we're measuring the distance between the wrist transform and the wrist elbow points. Alright, now let's take a look at the first two lines of code that we're going to be putting inside of function update. So first of all, we have hand transform dot rotation equal target dot rotation. So the target that we're going to go for, you can rotate any way that you want, which is going to make the hand fit more perfectly on the handle of the gun. So that's something that you can figure out how to adjust later. And then we are just going to have the rotation of the hand match that by doing hand transform dot rotation equal target dot rotation. And then the next line of code, you would think that we would have the hand position equal the target position, so the hand is always on the gun. But the only problem with that is that if the gun happens to extend beyond the reach of the arm, the hand will go with it. And if you have a mesh then that mesh is, I mean not a mesh, a character mesh with bones, that mesh is going to stretch out really far, and it's going to look really bad. And if they're separate game objects, the hand is just going to completely remove itself from the wrist. So to fix that, we're going to have the hand just always be on the wrist. So that way, when the gun, if it happens to move out of the reach of the character and then move back into the reach, it can kind of like throw it and catch it and give it that sort of a motion. And that will also make our engine much more versatile, and be able to do more things, because the whole arm stays together and continues to reach in the direction of the object that it wants to grab. Alright, the next line of code is transform.lookAt target, comma, transform.position minus elbow weight dot position. So basically, we're accessing the transform that is attached to the game object that this script is attached to, and the script is going to be attached to the shoulder parent game object, or really it's going to be the parent of the entire arm, and that is going to rotate and look at its target. The only problem is that when we are rotating and looking at the target, we have one more variable. Where does the arm move from there? So that is where, if we leave the next parameter of the function blank, it is by default going to be worldspace.up, which basically means a vector 3 that points straight up. So if you imagine yourself doing the function lookAt, just imagine yourself looking at something and then asking yourself, where is up? So if you say, well, up is this way, and I want to look at that thing over there, I'm going to angle my head to look at it. But say you're Spider-Man and you're on the side of the wall, to you, up is going to be that way, and then the way that you look at that thing is going to be different. So basically we're using the exact same concept, except we want up to be away from the elbow weight so that the elbow goes down. So essentially the arms up is in this direction. So that is why we're going to use transform.position minus elbow weight.position, because basically this is going to give us a vector 3. Like if we put the elbow weight somewhere back here, that is going to give us a vector 3 that points that way, that from the shoulder, or starting at the elbow weight point to the shoulder, and then just straight through that way. So that way the elbow always weights itself towards the elbow weight. Alright, now let's take a look at our next line of code, which is dist to target equal vector 3 dot distance target to position, comma, shoulder transform dot position. So dist to target is going to be a constantly changing variable that is going to tell us exactly how far away our gun is, or the target of what we are trying to reach at. And then we are simply going to use the variable vector3.distance, or not variable, the function vector3.distance, just like we did up here, to measure the distance between the shoulder and the target that we are reaching for, so that we always know how far away the target is. Now, this isn't a completely necessary line of code, but it does two things. Well, first of all, it shortens up how much we have to write, and third, it does make our code a little bit more efficient, because it doesn't have to call this function every time that we want to know the distance between the shoulder and the target that we are reaching for. So as you can see, we use it down here like once. I'm sure we use it many more times, but we use it a lot of times, and it's much easier to just write dist to target rather than this huge long line thing. Alright, now our next line of code right here, elbow z equals mathf pow dist to target, comma 2 minus mathf dot pow wrist length, comma 2 plus mathf dot pow shoulder length, comma 2, and all that divided by dist to target divided by 2 is basically this equation right here, because in our case, x is elbow z, or this distance right here, and then d, let me see if I can scroll up right here, where is d? D is the distance between the shoulder and the target that we are reaching for, and then little r, let's see, is the length of the forearm, and then big R is the length of the bicep, and then D is once again the distance between the shoulder and the target that we are reaching for. So basically I use this whole graph right here to translate all the variables that we are going to need and plug them into this equation here. And then when we put that all inside of Unity, it looks like this. So let's break this down. First of all, elbow Z, like I said, is the X that we're looking for. And then we have inside of parentheses this whole thing right here. And the first part of that is mathf.pow dist to target, comma 2. So mathf.pow means to the power of. So it's a function inside of mathf where you give it a variable and then you want to increase it by the power of something. And in this case, we want it to be squared or to the power of 2. So we put in a 2 right here. And then this will return us dist to target to the power of 2. And then we are going to minus wrist length to the power of 2. And then we are going to add shoulder length to the power of 2. And then we're going to divide that all by dist to target times 2. So you definitely want to make sure you get all the parentheses in the right place, just so that it matches up and looks the same as that equation I showed you on that math website earlier. Alright, now what our next line of code is going to do is place the wrist where we need it to, or basically it's going to snap the wrist to the target, but at the same time, if the target is too far away to grab, we don't want the wrist to go any farther than it actually is supposed to. So we're going to do wrist transform dot local position dot z. So this is going to make sure that the wrist only moves forward and backwards inside of the arm parent, so that it only goes forward and backwards and actually reaches at the target. So we're going to do mathf.clamp. Now the way mathf.clamp works is you give it one number and then you give it two more numbers, which are a minimum and a maximum. And if the first number you give it is larger than the minimum but smaller than the maximum, it will just give you that number back. Nothing has changed. But if it is smaller than the minimum, it will give you back the minimum. But if it is smaller than the maximum, it will give you back the maximum. So the first number we give it is vector3.distance. Actually, this whole thing could just be dist to target. Yeah, this can be dist to target. So dist to target. And it is blue because I'm inside of text edit. But whatever, go ahead and just ignore that. So dist to target, the distance between the shoulder and the target. And then 0, so the minimum. So we don't want it to go any smaller than 0 because 0 would be like going through itself backwards and going behind your head. We don't really want that. And then the maximum that we give it is wrist length plus shoulder length. So that is going to be the length of the shoulder plus the length of the wrist, and that gives us the length of the entire arm so that we know how far we don't want the wrist to go so that the elbow doesn't break in half right here. Alright, now let's take a look at, I'm lost myself. Okay, here it is. So let's take a look at this big section here. Now, it might be pretty hard to see, but basically what we are looking at is an if statement with two conditions inside of it, and then two lines of code that will happen if the two conditions of that if statement are true. So let me go ahead and move the microphone and move out of the way just to make sure I'm not standing in front of the code. And now let's take a look at the if statement and the first condition inside of it. So the first condition is if dist to target is smaller than shoulder length plus wrist length. So basically we're just making sure that the arm is long enough to reach the target that we are reaching for. Otherwise, we're going to pull up a different equation because we only want to call these next two equations if the target is close enough to grab. Now, the second condition is if dist to target is larger than mathf. Did a fly just land on my head? Anyways, if dist to target is larger than mathf.max shoulder length wrist length minus mathf.min shoulder length dot wrist length. So basically what this whole thing right here is the difference between the shoulder length and the wrist length. Now, depending on how your character is set up, most likely the bicep is going to be shoulder or longer than the wrist. But who knows? You might want to be artistic and make the wrist really long just to make your character look weird and lanky or something like that. So we don't know which one is going to be longer than or shorter than the other, but we need to find out the difference between the two of them. So we're going to use a function inside of mathf called max and min, which basically max and min, you give it two variables, and max will give you back the larger of the two variables, and min will give you back the smaller of the two variables. So when we put max first minus mathf.min, we are finding the difference between the length of the bicep and the forearm. So that way we know when the arm is bent all the way back like this, there's going to be a little gap after that. And we also want to make sure basically that the circles aren't inside of each other, if that makes sense. So basically so this whole if statement is if the target is close enough to grab, but not too close that it's so close that it's glitchy, then we will run these next two lines of code. Alright, so the first line of code that we have is shoulder transform dot local rotation equal quaternion dot Euler mathf a cosine, and then elbow length or elbow z divided by shoulder length times mathf dot rad to deg, comma 0, comma 0. Okay, so let's break this down. So first of all, we're affecting the local rotation of the shoulder. So that means we want the shoulder to rotate according to how its parent has already been rotated. So the parent is going to be the arm parent, which all of the different parts are going to be inside of. So we're affecting the local rotation of that. And then we are going to give it a quaternion dot Euler. So the function Euler inside of quaternion, you give it three variables in x, y, and z, and then it will take that Euler rotation and turn it into a quaternion so that we can plug that into the local rotation. And as you can see inside of the quaternion dot Euler function, we have something on the x-axis. So that gives us this rotation here because we're rotating around x. And then we have 0 and 0 on y and z because we don't need to rotate on those. We only need to rotate on the x. So now the first part inside of that x is mathf.acos elbow z divided by shoulder length. So elbow z is our adjacent side, and shoulder length is our hypotenuse. So adjacent over hypotenuse. And the reason why we're using a cosine instead of just cosine is because cosine by itself is just meant you give it the angle and then it will give you back a decimal number that is going to represent the ratio between these two numbers. Whereas a cosine does the complete opposite. You give it a number that represents the ratio between these two numbers, and then it will give you back the rotation. Okay, so basically right here, now we have the rotation in which we want the shoulder to rotate around the x-axis. The only problem is that this function returns it to us in radians. So radians are just like degrees, they measure angle, but radians are just different. I could go into why they are the amount that they are, but just know that it's kind of like transferring between American to Canadian money, US to Canadian money. There's a ratio of how much they are equal to each other. So that is why we need to multiply it by mathf.rad to deg, which is short for radian to degree, which is basically just a number or a saved variable, which is the ratio difference between radians and degrees. So after all of that is said and done, now our shoulder is rotated around the x-axis where it needs to be to meet up with the wrist at the elbow. Alright, so now we have the shoulder or the bicep rotated in the way in which we need it to be. Now we need to do the same thing with the wrist/forearm. So we are going to use this line of code right here, which is extremely similar to our last line of code, but just slightly different. So first of all, we are affecting wrist transform.local position, and we're using quaternion.Euler, just like we used up here. And just like we did up here, we are also putting 0 on the Y and 0 on the Z, and we're only putting something on the X. So first of all, it is negative because basically we want to flip it around because we are working backwards, whereas the shoulder, we were working forwards. So we're just going to flip it around so that it has because otherwise the wrist will want to point upwards. So then we would have two semi-parallel wrist and shoulder, and that would just look super glitchy. So we need to flip it so that the wrist actually meets up with the elbow. So we're going to use mathf.acosine, and then we are going to do dist to target minus elbow z, because elbow z is the distance between the shoulder and then to the point that is straight above the elbow, where now we want this distance right here. So we're going to do dist to target minus elbow z, so then we are left with this length right here. And then we are going to divide that all by wrist length. So basically, just like we had up here, elbow z, except we're doing dist to target minus elbow z, and up here we have shoulder length, and down here we have wrist length. So now we have the angle in radians of what the wrist needs to rotate to meet at the elbow, but now we need to turn it into degrees because it's in radians, so we're going to multiply it by mathf.rad2deg. And then after that, our wrist and shoulder should be rotated properly to meet at the elbow. And we have a few more lines of code, and these are two if statements with conditions inside of them. So if the target is too far away to grab or too close to be glitchy. All right, now let's take a look at this if statement and the lines of code inside of it. So this whole thing is going to be if the target is too far away to grab, then we're simply going to set the rotation of the arm to be 0, and I think we're also going to have the rotation of the wrist also be 0, because the arm is just reaching straight out because it wants to reach as close as it can, and the rotation of 0 and 0 is the closest that it can get to doing that. So the if statement is if dist to target is larger than or equal to shoulder length plus wrist length. So let's say our target is like right here, so it's the exact where we can reach. So we have shoulder length plus wrist length, and that is going to equal dist to target. And then after that, if it is farther than that, so larger than or equal to, so it's just going to reach as close as it can. So if the distance is larger than what we can reach, we're going to set shoulder transform.local rotation equal quaternion.Euler 0, 0, 0. And then we're going to do the same thing with the wrist. So wrist transform.local rotation equal quaternion.0, 0, 0. Now the next line of code is going to test to see if the target that we're trying to grab is too close to be glitchy, where the target is pretty much inside of your shoulder, but we still want the arm to still grab for it, because otherwise we're going to get glitches. So if it is just way too close, and the condition for that is if dist to target is smaller than or equal to mathf.max shoulder length, comma wrist length minus mathf.min shoulder length dot wrist length, or in short, the difference between the length of the shoulder and the wrist. So if it is smaller than or equal to that, we are going to set the rotation of the shoulder to be quaternion.Euler 0, 0, 0, so that it's pointing this way. And then the rotation, or the local rotation of the wrist transform is going to be quaternion.Euler 180, 0, 0. So the 180 is just going to flip it backwards. So basically the bicep is pointing straight this way, and the wrist is pointing straight this way. And I can't do it because this is real life, and I can't have my wrist go through my shoulder. But we're going to go ahead and make that be able to happen in the game, because you never know where the target you're reaching for is going to be, and we would rather not have glitches. So that was a lot of information. So if you guys have to go back and watch this video again, I know I would have to if I was watching this tutorial, because that was really complicated just to explain. So yes, let's now cut the green screen and go into Unity and show you how to do that inside of Unity. Alright, here we are inside of Unity. So, first things first, we need to resize the enemy. The enemy is a good size right now, but the problem is that the scale of the enemy body game object isn't 1:1:1. And for some reason, I haven't quite figured out why, but the inverse kinematic arms hate it when the parent game objects don't have a scale of 1:1:1. So I'm going to change the scale of this to 1:1:1. But the enemy is really, really tiny now. So let's go ahead, and I think I can select all of these objects just like that. And let's go ahead and scale them up a bit, and then relocate them to actually look right. So I don't know, I think that goes about there. Let's move the head to like right there. Left arm we want to be more like there. Actually, you know what, the left and right arm I'm just gonna delete because we're creating new ones anyways. And I'm gonna move that over, and I'm going to move that over, and that's a little off. And let's resize. Actually, I need to set this to scale 1:1:1. And I'm going to turn the box collider off and the mesh renderer off. And I'm going to press F so that I'm focused in on it. And then game object, create other cube. And I'm going to set that as a child of the enemy body torso. And I'm going to, where is enemy red material? So enemy red, I'm going to drag and drop it on top of there so that it matches. And then I'm going to resize it, resize it, resize it, resize it. Okay, that's good enough. Sort of, not really. It's actually kind of really bad looking, but whatever. Let's give that a save. Oh, we actually need to add, we need to change this to enemy body part, and we need to add an enemy body part script to it. So now let's give it a test run, and it looks like it appears to be working. He doesn't have arms, but he is still walking, and I should be able to shoot and kill him. Okay, there's one thing I forgot to do that looked really funny. Let's see, no, this has the rigid body on it. Oh, wait. Oh, it is because I deleted those two things. So let's temporarily change this to 4. So torso, and then the 2 legs. So left leg, right leg. Let's give that a save. Let's try it one more time. Hopefully this time when I shoot him, he actually goes all the way down and doesn't just get lazy. There we go. And he's dead. Okay, so that is totally working. So now I'm going to save that. And I'm going to go to enemy, and I'm going to change the unaware speed to 0.000001. Just really, really small. And I'm going to change the max move speed also to something really, really small, like 0.001, 0.000000001. Okay, whatever. And current move speed, 0. Okay. That should be good. So now the enemy shouldn't really move anywhere. It's going to want to move somewhere, but it's not going to. And it's saying the look rotation viewing vector is 0. So I think that means, I don't know if that's going to affect anything. No, we don't want to make it 0. 0.0001. Alright, now the look rotation viewing vector is still 0. Oh, it's because the current move speed is 0. Let's try 0.000001. See if that works. I'm still getting this error. But if I continue to get it later on, then I'm going to simply just increase these values until it's moving very slowly. And I just want the enemy moving slowly just so that I can look at the arms and adjust them more easily. So let's actually create some arms. So I'm going to go to the torso, and I'm going to create an empty game object. I'm going to make it a child of the torso, and I'm going to start with the right arm. So I'm going to call this arm parent R. Good enough. And we are going to move that. Whoops, let me select it. We are going to move it like about shoulder height ish. That should be good. And it was the right side, so over here is where I want it. And I'm going to press F to zoom or to center my focus onto it. So now when I create a new game object, I'm going to create a cube, it will create at the exact center of that. So I'm going to drag and drop that onto, what did I call it? Oh, arm parent R. And there's actually one more thing I need to create. Game object, create empty. And I'm going to make that a child of it. And I'm going to call this shoulder R. And I'm going to make the cube a child of that. And I'm going to make the cube a different size. So I'm going to scale it down. And then I'm going to scale it forward and out a little. Now when I click on this, and you definitely, during this whole editing part, you're definitely going to want to make sure that you have this set to pivot, because as you can see when I set it to center and I have shoulder R selected, the exact position of shoulder R is right here, but when it's set to center, it averages out the position of this game object plus all of the children inside of it. Or I guess it's the center of all of its children or something like that. So you want to make sure it's set to pivot to make sure that you can see exactly where everything is. So I'm actually going to make this a little bit shorter and move it back just a little bit. And that looks pretty good. So I'm going to select both of those and duplicate them. And I'm going to rename this wrist. And I'm going to move it to be more like there. Actually, I want it more like there. And then the cube, I'm going to move about there. And then I'm going to shorten it that way and shorten it that way. Now that looks pretty much perfect. Not really. Well, good enough. It'll work. Alright, now I'm going to press F to zoom in on, I guess now it's zoomed in on the cube, but whatever, that's fine. And I'm going to create an empty, and I'm going to move this to the elbow. So right about there, where I want the elbow to be. And I'm going to make this a child of shoulder R. And I'm going to call this shoulder R elbow point. And I'm going to do, I'm just going to duplicate it. Duplicate, put it over here, and I'm going to change the word shoulder to wrist. And the exact same position should be fine. Alright, so let's see. We have the arm. Oh, we need the hand. So I'm just going to go ahead and duplicate this, just because that's very simple to do. And for this, I'm going to move the cube about there. Actually, I'm going to need to move it again once it's the size of a hand. And that looks like a hand, whatever. But the hand doesn't need an elbow point, so I'm going to delete that. And I'm going to change it from wrist R to hand R. Hand R. Okay. I think that's everything. Or at least I hope that's everything. Oh, we need the elbow weights. That is what I'm forgetting. So I'm going to go to this and I'm going to create empty. I'm going to make it a child of the torso. And I'm going to call this elbow weight R. And then I'm going to move it kind of in that general area. Seems to be a good area that typically works. And you want to make sure that the elbow is not a child of the arm parent, because when the arm parent rotates, if this were a child of it, this would also rotate, when really we want this to be a point that is going to be relative to the torso. So you want it to be a child of the torso. Okay, what's next? Okay, so we need the script. So I'm going to create a new JavaScript. Inverse kinematic arm script. Okay, so I'm about to do something that normally I would not do. But because this video is already ridiculously long, I'm going to copy and paste the code. So copy, where's mono develop? Paste. So I just saved a whole bunch of time. So usually I go through and I re-explain everything, but because I already spent about an hour explaining what all of this code does in front of the green screen, I am just going to leave it at that, because you guys probably don't want me going through all of this stuff again. But what I am going to do is I'm going to try to clean up the code a little bit. And this, I want to go over here. So all of the lines that I broke up into multiple lines that were really one line, I'm just putting back together. And yeah, I think that's everything. I think that's all of it. Alright. So I think that'll work. Let's go into Unity and let's apply the inverse kinematic arm to the arm parent R. And let's take a look. We got no errors. So it looks like the script will be working. So now let's take the arm parent. Oh, we are also going to need a target. So what we are going to do to get a target is, first of all, we're going to import, well, what order should we do this in? I'm going to go to the torso, and I'm going to game object, create empty, and I'm going to call this gun parent, and I'm going to make that a child of the enemy torso, and I'm going to move it up to about the height that a gun would be. Move over. Okay. And then what I'm going to do is I'm going to right click down here, import new asset, downloads. I need to go into this, and here it goes. Okay, so you guys won't, well, I guess you sort of will need to do that step, but if you want this gun, go ahead and download the project files from the Unity forum that I will be posting in the, or I will be linking in the description of this video if you want this gun. Otherwise, you could just create a cube. There's nothing wrong with using cubes when you're just learning. And now I'm going to take that and I'm going to make it a child of that. And that looks pretty good. I think we'll just leave it like that. No, not actually. So let's rotate that 90 and let's scale it down. That looks good. Move it forward. Alright, that looks pretty good. Now we're going to create two empties. So we're going to call this target R. And where'd it go? Where is it? Target R. There it goes. Okay. And then we want this to be a child of the gun parent. And then we're going to move it where we want the right hand to go, which is going to be on the handle of the gun. So that should do. That should be pretty good. Cool. And now I'm going to duplicate this. Duplicate, and I'm going to call this target L. We might as well create the left-hand target while we're already inside the gun. And let's move that to the right-hand target. I assume that's the way you're supposed to hold the gun. Is this a one-handed gun? No, your first hand goes right here, right? You know, I think your second hand might actually is supposed to go right here, isn't it? Huh. Oops. Well, I guess that's an easy fix. Let's take the left hand, move it here, and now let's take the right hand and move it here. And that should be good. And of course, if you are working with a game object that is an advanced character with multiple body parts and fingers and all that, what you would want to do is edit the rotations of target L and target R to make the palm of the hand actually match up on the gun. And then from there, you would just want to pose the fingers and then just leave them as they are until you know, the enemy is killed and it's turned into a rigid body, in which the fingers will then move according to the rigid body and the ragdoll physics system. So yes, I believe that will work for the right arm once we set it up. So we need to fix up all these variables. So target is target R. Hand transform is hand R. Shoulder transform, shoulder R transform, shoulder elbow point. And shoulder length, we actually could hide that in the inspector because we don't need to know that. And then wrist transform, wrist R, and then the wrist elbow points, and then the elbow weight. and I believe that should be working. So let's go ahead and run it. And it looks like it's working. Alright, so now if I grab the gun parent and I edit the values over here, you can see the gun follows. And let me move the Z. And that's looking pretty sweet. It looks like it's working. It looks like there's some weird skew going on. Let me try to find. Usually that happens when you have a parent that doesn't have a scale of 1, 1, 1. Which, as you can see right here, this doesn't have a scale of 1, 1, 1 for some reason. So I'm going to scale it to 1, 1, 1. And now I need to rearrange these a little bit. And I need to make the cube a little longer. And Dimitri, I'm trying to make a tutorial. Get out of here. That's my dog. Okay, now let's move the wrist to where we want it to be. And then let's stretch the cube. Move it back a bit. Elbow point. Move it to the elbow. Whoops. Okay. And then shoulder. We just need to adjust the cube. Move it forward. Stretch it a little more. And make sure the elbow point is on the elbow. Give that a save and a run. And what happened? Okay, let's double check all our stuff. So the wrist is right there. Elbow point is right there. Shoulder. Other elbow point. Hand. Ah, it's the hand that's making it funky. There you go. Because you want the hand parent right here to actually match up with the wrist, and then the hand model itself to come out of that. So let's give that a run. And I still can't figure out what is making it do that. So scale of 1, 1, 1. Make sure all the parents have a scale of 1, 1, 1. Oh, the enemy torso does not have a scale of 1, 1, 1. This is actually supposed to be 1, 1, 1. Okay, more scaling to do. All right. So let's rescale this cube. Wow, look at that. Okay, this is what happens when you don't make sure right off the bat that all of your parents have a scale of 1, 1, 1. You should definitely make sure they all have a scale of 1, 1, 1 before you try to attach these objects. But just out of curiosity, I wonder if it works. I believe it does. So let me find the gun parent and let's move it around. It definitely looks like it's working. So, okay. So the enemy has an extremely weird shaped elongated arm and elongated gun. Let's just go ahead and fix it real quick. So the gun parent needs to have a scale of 1, 1, 1. Ooh, look, that fixed itself. That was nice of it. And now, let's see, make sure left hand, right hand, those are still where they need to be. And let's go ahead and move this more like right there. Arm parent, we want to move inwards right there. The hand, we are going to move like about right there. Cube, we are going to shorten it just a little. Make sure it's right where it needs to be. Actually, one thing that would make this all just a little bit easier to see is if I select all of these and I go to Component, Mesh Renderer, and then Component, Mesh Filter. We go to Filter, and we go to Sphere. Okay, maybe that didn't work as well as I had originally thought. But at least we can see all the points. But that's completely unusable. You can see where I was going with that though, about just creating meshes on these game objects so that you can see where they are and then later just turn the renderers off. But I'm just gonna go ahead and not do that. Okay, so now let's go to the shoulder and let's resize this cube. Resize it to about there. Move that about there. Make sure it's lined up. Yep, elbow point. Right there. Wrist. We want it to be back by the hand. And then the cube. A little... actually, I accidentally made the wrist way longer than the arm. Let's fix it. Alright, make that about there. And then let's make the elbow point right there. And now let's go to the shoulder elbow point. Whoops, shoulder elbow point. Put it about there. And then let's resize the cube. And let's resize it a little bit more. And I think that's everything. So let's save it, play it. Okay. And I am not seeing any skewing. Great. Awesome. So that means that it is working. So let's go ahead and click on that. So that then I can find the gun parent. And let's go ahead and just mess with it and double check to make sure it's all working. And it very much appears to be. Cool. Just checking all the rotations, even though pretty much if it's working in the first place, you know that it's going to work no matter what way you rotate it. Which is what's so cool about the inverse kinematic arm system. Okay. So now let's go ahead and take all of that and duplicate it. And I'm going to move it over and I'm going to rename this L. Arm parent L. And let's go ahead and rename this to hand L and shoulder L and wrist L. And I believe I also need to rename these L L, and I think that's everything. And now I need to where our enemy torso elbow weight. Duplicate it. Move it over. Elbow weight L. So now when we go to the arm parent, change the target R to target L. And the weight to elbow weight L. And I think it'll be working. So let's just go ahead and test to see if it's working, and it seems like it's working. So let's rotate it. Let's move it. Let's move it back a little. Make sure that elbow's yep, it's working. So we can put it like somewhere like that. And sweet. The inverse kinematic arms are working. But the only problem is that now if I try to kill the enemy, it probably is simply just not going to work. Let's see what will happen. It worked better than I thought it was going to. But it still didn't work exactly the way I wanted it to, because I want it to go fully into Ragdoll mode. So let's do that. Actually, I should have done that earlier because I was just creating more work for myself. But hey, whatever. So let's start with the gun. And let's create, let me press F. Let's create a cube. And let's make it a child of the gun parent. And I'm going to resize it. Make it a little longer. A little about there. That's good. And let's turn the render off. Give that a save. Now gun parent. Game object, component, physics, rigid body is kinematic set to on. That is step 1. Alright, now we need to go to, let's see, the hand. Alright, so let's add, whoops, I already got that one. Whoa, glitchy, okay. All of the hand, the shoulder, and the wrist on both the left and right arm, but not the arm parents. So let's go to component, physics, rigid body. Now component, physics, character joint. And now we're going to have to set these all up individually. So let's start with the left arm. So let's start with the hand. And the connected rigid body is going to be the wrist. And now let's move on to the wrist, and that is going to be the shoulder. And now let's move on to the shoulder, and that is going to be the torso. Now let's do the same thing over here. So we want wrist, click on the wrist, shoulder, click on the shoulder, torso. Okay, and now we have a little bit of work to do inside of the enemy body script. So first of all, we need to resize all of this. So far we have the head, torso, and the legs. So now we are going to need head, torso, 1, 2, 3, 1, 2, 3. So we have 6, 7, 8, 9, 10. And then with the gun is 11. Okay. So we ended with the right leg. So now let's move on to the hand right there. Shoulder. Wrist. Hand. Shoulder. Wrist. Did I count wrong? I think I did. Okay, head, torso, leg, leg. 1. I did. Okay. I got the wrist, and I need the shoulder. I've missed the shoulder of the L's. Okay. And now the shoulder of the right. Now the hand of the right is the only one I'm missing. And now the gun. Okay, and we're actually going to need to go inside of here and do a little bit of modification. And I'm going to need to go over to my text edit files over here to remember what that modification is. So we are going to create an array that is going to save the 2 ARM parent scripts, or if your character is a spider or something along that line, so that might be more like 8 ARM parent scripts, and then the gun script, and then down here, if health is smaller than 0, we are going to for loop through the ARM parents and disable them, and then we are going to disable the gun script. So let's go into Mono Develop and do that. So var arm parent scripts, and this is going to be inverse kinematic arm script, opening and closing square bracket to show that it's an array. Now var gun parent script, and we're just going to, oh wait, that's right, we didn't create the gun script yet. So we will be adding that part in the next episode or the episode after that. I can't really remember. So now let's create a for loop down here. So inside of the if statement, which says if health is smaller than or equal to 0, var arm parent script for in arm parent scripts, and we're going to do arm parent script for dot enabled equal false. Excuse me. All right. So I think I just spelled that right. Okay. So now let's go into Unity, see if I get any errors. No errors. All right. And the arm parent script, we're going to set that to size 2. And the left one and the right one. And now when we kill the enemy, that's not supposed to happen. We forgot to take all of these, and the rigid body set to is kinematic. Now let's give it a run. Much better. Okay. And now when I kill him, let's go in there. Nice headshot. Yeah. And it kind of fell apart. Why did it fall apart? Oh, wait. Yeah, all my joints are centered, right? Looks like it. So why would they fall apart? Okay, I figured out the solution. It was a quick, easy fix that I just forgot to do. So what we're going to do is we're going to select wrist L and wrist R, and under anchor we're going to set Z to, well, it depends on your game. There's no exact answer to this, but if you just take a look at these little arrows that represent the anchor of the character joint, you just want to move them backwards until they're at the elbow. So let's give that a save and a run, and that should be working. And it is. Awesome. So of course though, if you were to actually set up the joints in the correct manner, you wouldn't have stuff like your elbows bending backwards. So if you do have like a nice looking mesh with all the correct body parts, I would highly recommend using the the Unity Ragdoll Wizard. That would probably do a pretty good job. Otherwise, you can just fiddle with the joints until you get them the exact way that you want. But for now, since it looks really ugly and it's made of cubes anyways, we're going to go ahead and leave it like this. So yeah, I think that is everything that I wanted to put in this episode. But before I go, I actually want to show you guys one more thing. So I'm going to go, let me use these stairs for a demonstration. So a couple of you guys have already noticed this, but if you try to just stand on some stairs, you slide down. So it's not the biggest issue in the world, but it's kind of been annoying me for the longest time because it's not been a big enough issue that like it was super necessary, but I also couldn't figure out how to get it to stop doing that. But I finally figured out how to get it to stop doing it, and it's extremely simple. So let me find the player movement script. So go to the player movement script, and then anywhere inside of the update loop, we're going to write if grounded rigid body dot use gravity equal false, and then else rigid body dot use gravity equal true. Simple as that. So if we are already on the ground, we don't need to worry about gravity because we're just standing there. But if we are jumping in the air, we're going to turn gravity back on. And if I play the game, you'll be able to see that there really isn't any difference. It's still behaving perfectly normal. But once I start walking up these stairs, actually down them, I no longer slide down the stairs, which is totally awesome. It is a little bit bouncy going up and down stairs, but I feel like that's pretty natural anyways, because when you go up and down stairs, your head kind of bobs up and down a little bit. But either way, I think it works like 20 times better. Well, you still get a little bit of glitch from the going up and down stairs ramp, but it's not nearly as noticeable, and I don't think anybody playing your game is going to notice that. So yeah, now you can actually stand on stairs and slopes without sliding around. One more glitch fix that I wanted to show. So sometimes when your computer runs at a slow frame rate, or for whatever reason, sometimes the capsule comes into collision with the collision detection sphere. So I really should have done this right off the bat. But what we're going to do is we're going to go to collision detection sphere, add layer, layer 10, I guess we're on, and we're going to call this collision detection sphere. Now let's go back to the collision detection sphere and put it on that layer. Alright, and now let's see, is the player capsule needs to be put on a layer. So whoops, I guess no, just this object, even though I didn't change it. But let's add one more layer, and we're going to call this layer player. And let's go to the player capsule, change layer, player, no, this game object only. And now we want to go into edit, project settings, physics, and now let's find collision detection sphere and player, and uncheck that box right there. And now the player and the collision detection sphere will not interact with each other. So, I mean, there's really no good way for me to demonstrate whether or not this is working, because it was one of those things where it's like a glitch that only happened every once in a while. But it definitely makes a noticeable difference, in my opinion. Like, the jumping and movement definitely just works a lot better now. So yeah, I think that pretty much wraps FPS 1.42 up. So now we are done with that. So our next episode, I guess we will be actually creating the behavior of the gun and actually being able to make it shoot. And then the episode after that, we will make it so that the enemy can kill the player, and that should be a pretty easy, straightforward episode. It's really not that hard. I'm not sure if that's exactly how the tutorials are going to go. I'm going to have to plan it out a little bit because the movement of the gun is pretty complicated. I might cut that up into 2 tutorials. I guess we'll see. But either way, until my next episode, I'll see you guys later, and keep making games.